Okay, sir. Now, see, there are different types of, when I say backup protection, in the previous slide, I spoke about backup protection, right? See, when I say backup protection, see what if there is a fault, this breaker has to trip first, then this breaker has to trip, right? That is backup protection. In other words, these two breakers have to coordinate with themselves. See, look at this word coordination comes from backup. See, why should two people coordinate? The two people has to coordinate with each other. So, for example, I am talking, you are listening, you will talk, I will listen. So we are also coordinating with each other, right? Why we are coordinating? Because there is a relation between us. I am taking class, you are listening to me, that is a relation. So without relation, there will be no coordination, right? Some breaker somewhere here, I will not coordinate with this. The coordination is between those who are related. And what is the relation here? Like father and son, it's a backup protection. Okay. So when we do this coordination, there are different types of coordination. Okay, you can coordinate using current, you can coordinate using time, you can like you can coordinate without current and time also. Okay, so some of them, what is common, let me tell you. Now, when you're doing current coordination, normally our buildings where we use MCB, it is current coordination we are using. How we are doing current coordination? If you pick up your ABB or some of the company, they are giving coordination tables for these small breakers. So I will go and ask our Pinaki Sharma. Pinaki ji, you are working on a lot of these low voltage power distribution, right?
Yes, sir.
Yeah. So you design, you prepare single line diagram. So
Yes.
suppose you have a breaker, incomer is 64 amps MCB. What is the maximum outgoing breaker rating we can put?
Uh, Maximum we can keep it will be 32 amps.
Okay.
Incoming is 64.
Okay.
Outgoing, I would think would be 32. There should be a 1.6 times. The breaker should be 1.26 times the incoming. Outgoing should be 1.6 times the incoming.
Okay. This is the UK wiring rule.
It's something which is used because generally we don't use ABB products, sir. We go for Schneider.
Schneider.
So for Schneider, the thumb rule is 1.6 times
Okay.
MCB to MCB.
That K here techniques.
Yes.
Okay. Okay. So, like normally to practice, like some of us, what we do, like even Mr. Our friend said, we will maintain. Suppose incomer is 63 amps, my outgoing feeder will be 32 amps or something like that. So that is the current coordination, right? So that is very common in low voltage where we have MCBs. MCB and MCCB. What is the difference, Naveen ji? MCB and MCCB?
Yes, sir. This is a miniature circuit breaker. Actually, MCCB is molded case circuit breaker, which is for higher rating. MCCB is more than 63 ampere. We will use.
So MCCB is having a can have a trip coil with a The MCB also will have a small coil inside, but one difference, MCB I can't do the setting. MCCB I can do the setting. I can actually, in MCCB we have, how many of you have come across this one, electronic trip unit?
Yes, sir.
We'll come across
We
it.
know.
Yeah.
I came across.
Thermomagnetic trip unit, Vijay Kumar ji, you have come across this word, thermomagnetic trip unit?
Yeah, yeah,
Yeah.
yeah. So the basic difference is you will have a range for thermal and magnetic settings. So it is in fixed range, around 0.4 to 1 times the IN rating, which is the current rating of the circuit breaker, and then your the magnetic setting, magnetic trip setting is around it again depends on type of breaker, so we talk around 5 to 10 times the current setting.
Okay.
But in terms of electronic trip units, you can go for a discrete setting. I mean, here you have fixed settings like in thermal magnetic trip units, you'll have fixed settings like 0.8, 0.7, or point something like that. But in electronic trip units, I think you have it comes from lower range.
Correct. Thank you, Vijay ji. So we have electronic trip units, we have thermomagnetic trip units, and when we do the coordination, we have to add the curves of this one also in the coordination. And these curves actually, they don't follow exactly the IEC curve or IEEE curve. They are custom made curve by the manufacturer. They are close to those curves, but not exactly. So you can later on, there you have something called LSIG, long, short, instantaneous, those sort of curves. I can share you some links also on this electromagnetic trip unit and electronic trip unit, thermomagnetic trip units. I will share some in the WhatsApp group, go through them. So in current coordination, basically what I want to say is, we don't go for this, we don't check the time. See, once I use 32 amps MCB and 6 amps MCB, I need not check my timing. Okay, I need not draw any curve because I cannot play here. I cannot change the settings also. Okay, so that is what I want to convey here. Okay, now let us go to time-based coordination. Able to see this curve?
Sir, excuse me, sir.
Yes, sir.
Could you please go earlier slide?
Yes, sir. Please tell me.
So here, total 6 number of outgoing feeder. Out of 6, 5 is 6 ampere MCB, and another one is 16 ampere.
Yeah.
So how do you coordinate by 32 ampere? Could you please explain this one?
Sir, in the first place, you are asking question 1, 2, 3, 4, 5, 6. 5 are 30. It will be 46 amps. That is what you are feeling.
Sort of like this.
Okay, sir. Actually, see, I will tell you the size of this one depends on the overall load on this switchgear. Actually, here the load may be 2 amp, 2 amp, 2 amp. This load may be 2 amp, 2 amp. This load may be not so high, maybe like 10 amps. See, normally the load based on the overall load. See, we have, when you do our switchgear sizing, you will see we will take all the loads and we will take all loads are not loaded at the same time. So we have those factors. So when we take those, we will get, let's say, the total load here may not be more than 20 amps. You will see that the load here in the switchgear may not be 20 amps. So we have gone for a 32 amps breaker, something like that. So these are all the lighting circuits. I'll tell you in simple, if you go to our simple domestic house, this represent a house, all these lighting circuits, and this is my power socket. So if you go in any of our building houses, my power circuit is 16 amps. So that is why this is 16. The reason why this is 6 is because it is lighting circuit. And when I combine all these, the size of the incomer breaker is not addition of all this. I have to write down my load schedule. I have to prepare a schedule, and there I have to determine the total power consumed by this house or building, and then I have to determine the incomer breaker rating. And normally the incomer rating, and I have to take all the load factors. When I take those factors, the rating of this breaker will come less. Am I correct, Mr. Pinaki?
Yes, sir.
Yeah,
You're right, sir.
yeah.
It's a
So,
diversified load at the panel level.
yes, sir. Clear, Mr. Inamul? Inamulji?
Yeah, yeah, I understood, sir.
Okay. And coming back to this time coordination. One was, see here, the coordination is based on time. Means if there is a fault here, first this guy has to trip, then this guy has to trip, then this guy has to trip. Okay. One by one, they have to trip. That is why I'm using the word coordination. And see, if there is a fault here, if this breaker, the downstream trips at let's say 100 millisecond, this breaker, the next upstream will trip at let's say 200 millisecond, then this incomer breaker will trip at let's say 300 millisecond. So that is what coordination. Coordination means you all have seen the the running race where there is a relay. One person runs, gives a baton, other person takes it, runs, gives it to the other guy, right? So that is coordination. Same way here also, after this guy trip, this guy will trip, after this guy trip, this guy will trip. But do these two guys communicate? Do these two guys communicate? Naveen Kumar,
Sir,
will these two breaker communicate? Will these two breaker communicate?
it's depending upon our settings, sir. Like if we give the low time setting, the first will get tripped, sir.
Okay.
It will be coordinated depending upon the time settings.
Time setting. But we can also do like these two communicate with each other and then they trip. We can do that, right?
Yes, sir. With some schematics change, we can communicate with one breaker to another.
Yeah, correct. So
It is the concept of like trading. We do some kind of hardwiring.
yeah, correct. Gauravji, yes, you are switchgear manufacturer. You know the schematics better. You are correct. By wiring, we can make them coordinate. We can make them communicate. So the one more way, if let's say these two guys are not communicating with each other, then how do I coordinate? See, the railways, the train are going, right? 3 trains are going on the same track. The trains should not collide with each other. They should not hit each other. So what do? I will tell my train driver, this is your speed setting. Don't exceed beyond this. Number 1. Number 2, I will tell the train driver, the first one leaves at 10 o'clock. The second guy leaves at 11 o'clock. The third guy leaves at 12 o'clock. So even if these 3 fellows don't have communicate with each other, still they will not collide because all three have left the station in different time, right? Same with your aeroplanes, they maintain different distance. They have their own height at which they fly. Same way our electrical also. Okay. See, today, maybe after another 10 years, this subject called coordination may not be there. God alone knows. Because if all these breakers are right now, as on today itself, we have hard wiring through schematics. We can go for soft also. All these breakers have relay, and relays have communication port. I can make them all communicate with each other with a central station, and I can see to it that immediately after a fault, first this will trip, then this will trip. I don't no longer need this coordination. But still, we have not come to that stage. We are still using coordination. Maybe in future, this may not be there. It's my guesswork. Okay. So, in time coordination, what we are doing very simple. First, this fellow will trip, then this fellow will trip, then this fellow will trip. And without any communication among them, they will trip. How? This fellow will sense the fault. When there is a fault here of 5.4 kA, the fault flows from here. Okay. Since the fault is flowing from here, this one, this one, this one, all the breakers, all four breakers will see the fault current. And all breakers have current transformer, they will see the fault current. Okay. Krishna Kumarji.
Yes, sir.
So this red color circle, the CT rating, this blue color circle, CT rating, which one is higher?
CT rating for red color, sir, because it's an incomer, so load current will be more there.
Yeah.
Bus bar load current will come there.
Correct, sir. Since this is incomer, breaker rating will be high and the CT rating will be high. So this CT is, let's say, I will give it 1000 amps. If I give it 1000 amps CT, what will happen if I give 1000 amps CT? And this one, let's say I will give 250 amps. So for 1000 amps, 5K is how much? This is 5 times. For 250 amps, it is 20 times. So you can see this breaker is seeing 5 times current, this breaker is seeing 20 times current. So this breaker will operate faster than this. That is time coordination. I will explain that again. So if you understood 5% of what I said now, be happy, because gradually you will understand more. Okay. Any doubts here?
No, sir.
Yeah. So you are able to see the curve here. See here, red curve is here, green breaker curve is here, blue breaker curve is here. And what you can see, the curves are one above the other. And between them, there is a gap, right? And if all the curves are overlapped, then there's no coordination. Huh? Or if red breaker curve comes down below the green, then we will say no coordination. I will explain this again. Okay, right now, as I'm telling you, if you are able to understand little bit of what I said also, it is great. Okay, so Inamulji.
Sir,
If my red curve is below blue curve, is it okay?
no, because according to your explanation and the coordination, it should be higher time.
You are correct. Gauravji, did you understand this concept?
Yes, sir, because red has to bear the fault for the longer period of time. So for the same amount of current, red line should be above. So it, being above tells that red breaker is taking more time to trip at the same fault level, and that is what is required.
Okay, sir. Okay, you are correct. So, see, when I say coordination finally will come in form of a graph, and that graph is this one. And in that graph, I have to put all the curves of all the breaker, and there has to be, which curve has to come above who is very important. Simple. Who has to, in your office, also when they prepare the hierarchy table, right, in our office. So the top man will be in the top of the triangle. The next people will be at the bottom, so on. Same way, in coordination, very important. First thing in coordination is which curve has to come above, which curve has to come below. If you are able to understand that, 50% of coordination. Okay. So later on, I will explain you how we can move the curve up and down, how we can move the curve left and right. See, coordination is like a game we are playing. Move the curve up and down, move the curve left and right. Okay, and we give a difference.
This between the curve you told us, sir, the time maybe 100 millisecond or
I will explain, sir. That is called
Okay.
coordination margin. I will come to that coordination margin. I will explain that. I'll explain
Okay.
it. Now, you look at the shape of this curve. That also there is a IEC curve, IEEE curves. I will explain that also. Shape of curve, what are the different types of curve, what is their equation, why the curves are being shaped like this, what is the cause, that also I will explain. And one more point, why, okay, let me go to our Pinaki Sharma ji. Why time is in y-axis and I is in x-axis?
Because I think what happens is
Guesswork. Also, okay, fine. Can even guess some answer. Okay, why the time axis is in y-axis? Okay, or I put one more question. Why am I taking the current in x-axis?
because it's exponential. That's why you're looking at it in exponential values. Is it because of that?
But
Logarithmic values?
logarithmic, yes, that is the reason. You are correct. Because it is logarithmic scale, that is why my current has come to this one. You are correct. Because even I thought, I also was always thinking, why don't I shift my I to y-axis and t in x-axis? What difference it makes? I always used to think. Then I realized, okay, because it is logarithmic scale, so it will be little bit difficult. So you are correct. Now coming to interlocking, how many of you have used this zone selective interlocking or these interlockings? See,
I've used it, so.
Pinaki ji, you have used. Okay. Gaurav ji, you have used.
Sir, I have mostly read it in catalog, but I've never used it.
Okay, sir. Inamul ji, you have used interlocking.
Yes, sir. 33 by 11 kV substation we use.
Okay. You can share any interlocking diagrams if you have, you can share in the WhatsApp group just for our reference.
You're talking about normal interlocking or zone selective?
No, I'm not talking about the normal interlocking, sir. I'm talking
That we have done.
between incomer and outgoing. The moment the outgoing trips, the incomer has to trip. That interlocking I'm talking.
Okay.
So if Gauravji, you have any schematics or something, you can also share. Particularly,
Okay.
the outgoing breaker has to trip, then the incomer has to trip. If you share that, we can discuss that also. So this interlocking, some people go for this method also. What they do is see, this is if there's a fault here, this breaker trips. And as soon as this breaker opens, I will take the NONC contact and I will put one more, I know it will close one more contact in the trip coil of this breaker. So when I go for interlocking, see, actually speaking, if there is if this breaker open, if this breaker fails, only then I have to open this, right? Yeah. So, if this breaker has not opened, only then I have to open this. Okay. So schematics I can work out. I can work out the schematic, give some delay or something. So they have something called zone selective interlocking. Also in Schneider, I had come across this. How many of you come across this zone selective interlocking Schneider breaker?
Yes.
Okay. See, interlocking method is not so common, but just for sake of completeness, I have covered. I had seen this few years back, but later on, even I have not seen much. If you have anything on this, you can share. We can go through it. Okay. Now, tomorrow I will cover this. One of you asked, can you please let us know what you cover tomorrow? I will tell that also. Tomorrow I will cover damage curve of the transformer, I squared T curve of the cable, damage curve for motors. Okay, heat transfer in a motor, thermal curve of a motor, and motor data sheet. Okay, these things I will cover tomorrow. Okay. Now coming back to today's this one. Let me stop sharing my screen. I will just brush up what we have brush up whatever we have gone through today. Are you able to see my screen?
Yes, sir.
Okay, sir. See today what all we covered? Can you quickly tell me on it? Okay, what all we covered today? Can you? Today we covered what is the purpose of the relay. So suppose there is a fault here. The fault current will flow like this. Both these breakers will see the fault, and the CT will secondary pick up the fault current. It gives to a relay, and this relay trips the breaker. So the first purpose of the relay is to trip the breaker. That is the first purpose, trip the breaker. Okay, and we have, you can see, I have a breaker here, I have a breaker here. Now these two breakers, both of them see the fault, but both should not trip. Okay, only this one should trip. And if there is, so that is, then I spoke about selectivity. Okay, then I spoke about backup protection. This guy is a backup for this guy. That is why it's a backup protection. Okay. And then I spoke about current coordination. If I go for simple MCB, let's say I go for 32 amps here and 6 amps here, I need not draw the curves. MCB don't have any curves. Had this been a MCCB, then there would have been a curve, something like this, LSIG curve. Whereas MCB don't have a curve. Okay. Then I spoke about time coordination. Now these two breakers. Okay. Now this breaker and this breaker. Okay, we have what is called as time coordination. This one is coordination margin. I will explain about coordination margin later on. Okay, interlocking, I've already told. Any doubts in today's session? Any doubts in today's session?
You told now that whenever a fault comes, it will go from source to that fault location. Same like if motor feeding to the fault means that also will sense by the CT and the relay.
I didn't get you, sir.
Sir, actually you showed just now you drawn now, sir. When fault occurs, this from source to this fault it is feeding.
Yeah,
That fault current.
yeah.
So in the same case, if due to inertia, if motor is running, it may also feed the fault now, sir.
Yes, sir. Motor also will feed the fault. That I will explain to you tomorrow. You're exactly correct.
Okay.
Also feeds the fault.
So that time this it is flowing in the reverse direction. Those that CT will sense it. That motor feeders CT.
Sir, when there is a fault, if the fault is here, that CT will not sense. Sir.
CT because it's reverse. It will not sense.
The fault is at the downstream. This CT will not sense the motor contribution.
Okay.
But we will discuss this particular point again when we are talking on the motor. Okay, sir?
Okay.
Yeah. I think it's almost, I think another 5 minutes we will close. The session also will end. Anything more, sir? Any doubts you have, you post it in the group also. Tomorrow when we start, we will clear the doubts and go further. Okay? Okay, sir. Shall we close for the day?
Okay.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir. Thank you everybody for joining the first.
Thank you. Sir, will you be sharing these recordings to our mail, sir, as and when they're happening, or how will you?
I will put them in a YouTube, this one, and I will share the link, private access. All your email IDs, you post your email IDs, Google mail ID in the WhatsApp group. I will give the link access to that. Okay, sir.
Okay, sir.
Okay.
Thank you.
Now did
Thank you.
I think the echo got reduced slightly now.
Yes, sir.
Yes, sir.
Okay, sir. Thank you. Thank you very much, sir. Take care. Stay safe. Thank you very much. Tomorrow we'll start sharp 9 o'clock. Before I